Hi, can you hear me? Yes, sir. Good evening, sir.
Good evening.
Audible?
I'm audible, right?
Yes, sir.
So just will class. Everyone is there, or we should wait for someone? Can start, or we should wait?
Sir, this is 2 minutes, sir.
Okay.
Sir, you could start, sir.
Okay. Yeah. Hi. Good afternoon. Hi, Tim. So good afternoon. So this is one of the other area Exafluence is working, which is an IOT. So I have. I'll take half portion of this because I work on these projects, and the other portion my colleague Kusma will handle, which is on supply chain management. That's SCM. Okay. So you have, can you see my screen where you have a you can see the screen, right? My screen visible. Can someone answer?
Sir, the screen is visible. That is visible.
Okay. So we see this is the continuous monitoring, prevention, and predictor platform. So what do you think it by meaning of it? So these are three operations what we are doing in this particular objective of this is continuous monitoring, and we are doing the prevention and also prediction part of it. So this is completely done in industrial environment. What you are seeing is basically this is a real-time project. What we did in Amron Amaraja plant, which consists of this particular machine is a heat when you see a battery, you see the old type batteries that you will have a lead. There's a lead bulbs will coming out, which where we connect in the cars and all. We connect the cable to them. Even in the bikes and all, we connect the cable. So this particular machine, it is a part of a particular flow where the batteries are coming and the batteries will get ups and down, and this portion what you are seeing is a will have a lead, and they have a heaters which will heat the lead, and it will be in the melted molten stage, and the battery will go there, get dipped, and comes out of in the conveyor belt. This we are working. I'm showing the model only a part of a conveyor belt. What we do is, I'll explain what exactly we are doing and what type of data we are collecting here, and what is the analytics, what is the IoT, what is the or machine learning or our analytics for playing a role here. Okay, what we do is this particular mission has a multiple devices. Like any mission will have a motor, it's a conveyor belt. It once it has a it's a coolant, and we have a safety valves, energy control panels, motor, heaters, and temperatures. This is temperatures of the heaters which is in the to melt the lead. Okay, now now a small example, you're all will be, I'll take a motor as an example. So in a motor, what all we have, like, components, like, it'll have a current, it'll have a voltage, it'll have a torque, and you can have it like, this vibration. I am taking the example of a motor here. What is temperature, vibration, current, and voltage. Maybe some of you from mechanical background or engineering background, when the torque increases in a motor, when is the torque increases in a motor? This is a common question I'm asking. Anyone can answer for me? No answers? Okay. So for the interest of time, I just want first to go for this. So when the torque, say suppose there is this motor, you must have seen, all of you, it's a common example of I have taken. It's in the motor, you'll have a windings, and the winding will take the current and current, and there be a torque. There is a motor which is driving the motor. There is a torque. There is a shaft which is driving the motor. And once you drive the motor, when there's a bearing inside the motors. Once we have any problem in a bearing, and the speed of the bearing, because of the irregular bearing things, it will take more torque. The more the torque, more the current, and will be drawing it. So what we are doing is in prevention is basically continuous monitoring of a motor. So we will have a fixed, like, by observations or by the law, we'll have a fixed temperature, we'll have a fixed current, fixed voltage, and fixed vibration of the motors, where this will be fixed in the sense as standard things. So that is, we will be we'll get the data from PLC of what is the motor current presently, what is the vibrate torque, what is the current, what is the voltage, and we will be completely observing them. What is the present situation? Observing in the sense the software will observe what is the present situation, and we will give plus or minus 5 or 10% as a variable. Once because of the malfunction of the motor, if the variable changes, and this particular software or particular application will give us the alarm saying that first particular motor is having a problem. So that is first thing. So what we are doing is continuous monitoring of, I told an example, but we will be monitoring all the devices in a machine. So we'll monitor temperature, we'll monitor motors, we'll monitor energy, we'll panels, and if multiple motors, and even the for temperatures, we'll have the heaters, we'll monitor the temperature, how much it is going. Any variation will give the alarm through the software. The alarm will go to the respective employees, like, there'll be maintenance people. The alarm will go to the maintenance people. The maintenance people will raise a ticket saying this particular mission, particular thing has a problem. So the operator will exist, like, if it's a current based problem, the current guy, like, a guy who's maintaining the motor machines, he'll come and see what is happening, whether it requires any attention to the particular motor. So what we are doing there, so we are monitoring and we aren't preventing it. So suppose what will happen if we doesn't know what is the temperature, what is the power it is raising, there will be a sudden failure of the motor. So the failure of the motor will have the machine will the cut down the time of the breakdown causes delay in the production. So what we are doing by monitoring continuously, we are preventing the damages. You're getting my point? So we are monitoring it. We are monitoring all the devices, and if there is if it is any fault, then it will alarm. It generates an alarm. By generating the alarm before failure, we are doing the prevention. So are you clear with the monitoring and prevention? I expect an answer from many of you, because I just want to ascertain whether you are clear on this or not. So can they talk, or what is the problem?
Sir, clear, sir.
You are clear, right?
No, sir. Just a minute.
You have any doubt up to this?
Yeah. Yeah, sir. Like,
Tell me.
I have a small query. Like, how does that heat sink works for this motor, and how do continuous monitoring is present in a, like, if it is continuous monitoring, the transistors or the RAM of that, it like increases the heat, right? So how do you control that? Like, usually when it continuous process, the like, I mean, like the microprocessor or the chips or semiconductor devices which were used in this monitoring, like, and this monitoring prevents, so it's all get heated, right?
No,
So how do
is
you
that
control that heat
no,
when it was in continuous?
see, we are not working on the battery. See, it is in the mechanical devices. What we are working is, this is a mechanical device. Mechanical device, we are monitoring the different motors. So now it will not, why it will have a, I mean, you're talking about electronic devices. This is, we are talking about a heavy manufacturing machine, which has the multiple mechanical devices. We are monitoring the mechanical products, and this is coming to a software. The software is again, we host it in a server, which will server is, this application is monitoring it. There is no physical heat in the, for the monitoring point of view, right? This is hosted in an application is hosted in our regular servers, and we are monitoring the mechanical devices using a sensors. So the sensors are basically designed. Okay, now you coming back to your, maybe you're asking about the sensors. Sensors have a two type of sensors are there, which is a mechanical sensors, which will be completely, will have a probe which will be fixed to the particular where you have to measure the temperature. We'll have a probe which will be withstand so high temperatures. We'll keep the probe there. And second thing is, the next point of it is, if it's not the probe, then we'll have a static devices, which is static is where you connect to the particular where the temperature or voltage has to be there. So there will be mechanical as well as the static sensors, which will be collecting the data, and the data will come to, because that's a bigger subject. The data will come to the middleware, where will the middleware will convert into the values and push here. Am I clear?
Yes, sir.
Okay, we are monitoring that. So when I'm on, when you have the answers, maybe when I'm next time in office, I'll explain you clearly. This is how it works. So this, once we are continuously monitoring this, so we have continuously monitoring, and by attending, we are doing the prevention, and we say, so this is basically like, we'll have a real-time dashboards like this. So this basically, the dashboards are giving the multiple things. If there is a problem, it will raise a ticket. So it's now this is only a demo. I can't show you the original application which is running in a client space. So we just made this demo to make you to understand what is IoT, what we are working on. So this basically gives this will be on a monitored televisions, or it will where we can, it's called NOG boards, where this all data will be continuously displayed in a laptop, or it could be on a big multiple screens where somebody sits, and when there is a flag, and this like this will be monitored. So I am talking about one mission. Now the complete conveyor belt have multiple missions. So what we do is, we do the complete factory monitoring, connecting multiple devices like sensors, or it will, for latest missions, will have a PLC. We'll get the data of PLCs and push this into the software of our software, where we start monitoring them. So why we do monitor is, where we are first is preventing the unnecessary breakdowns. So second major thing is, we are giving analytics point of it. So the manufacturing data will come and store in a data lake, we call. Once it stores in a data lake, we will do the data lake analytics, where say we'll have the expected outcome. Say we'll say, for example, these batteries, we are planned for 1,000 batteries per day in particular conveyor belt or one line. So says production is coming to 800. we will do the analysis, where the time loss is there. So we have the data here. We can do the analysis, understanding which mission is giving a more problem, or what is the root cause of loss of the data, loss of the production. So with that, what we do is we control the whole of the situation. And this can happen in the sitting, like CEO or the CMD can get all this data, and we can do the analytics. A manufacturing data analytics, like what is the expected production, how much time is the downtime, how much time which mission is down, and what is the reason, whether it's a mechanical or electrical. Mechanical would have been prevented, or electrical could have prevented. So we give from the data lake, which is from this one motor, what we are getting, one machine, what we are getting, we get the same data for multiple machines and push that into a data lake. From the data lake, we do the analytics. Thereby, what we are maintaining continuous monitoring we are doing, and we are preventing. I'll talk about predictive analytics a little later. So this about the data lake and doing the analytics, where the data science is applied for the manufacturing thing. So where we in the manufacturing industry, all this data we can give any type of say, for example, you have a month's data, and of how many missions are how many products have come, or what is the, like what time it started. Say suppose you are supposed to start by 7 o'clock, what time the mission has started, whether it has started late because of the maintenance or because of the operator late coming. So multiple things you can generate. Once you have a data, you can do a lot of things. So the manufacturing data is usually called as data lake, which is from multiple sensors, multiple PLCs, and multiple production data. All this is put together, and we do the data analytics using this. So that is the analytics part of it. So here, what is the predictive things I'll just make you to understand. So this softwares. One second. Yeah, it'll take some time to load. So when it loads. So now these two parts are there. So these are the multiple things so we have a real-time real-time data monitoring, and we can give the efficiency, and we can keep the alerts, like what different type of alerts we can keep, and like in admin we can create the we can have the one second. See the just. So this is the different configurations we do. So what will happen is, so alert configuration you see. So this is the device we have. This is a sensor ID we'll have. We will fix the high value, which is reasonably okay, and we'll fix the high value, which is low value, low value, and status. So what will happen is, as I said, this is a only demo, will not have data. So this particular software will work on this particular alarms what we fixed. When it's in if any heater reaches a high, it'll give the first alarm. If it's more, then it gives the high. If it's a low, it gives a low and goes for low. This is how the complete alarm will background we can be configured. So when this actually it takes around 1-2-3 hours. Will once you are IoT we have your curriculum talks about IoT applications. Once you are really working on that, we'll give you real time exposure to this, where you can start working on an industrial data lake. I will just wait a graph. I just want to show that. Yeah, yeah. Okay. So what is happening here is, so now we have a history. So we have the history of, say, a particular motor. So what was the temperature, what is the torque, and all those things. So what we'll do is, this is the real time. What you see in the green is the real time. And what is the prediction is basically, usually there will be a pattern. So suppose there's a bearing failure. What I said again, I am tracking the motor because you all can visualize it easily. So motor will fail when there is a torque. When there is a bearing problem usually, or there is a coil problem, the temperature and the current draw will be high. So we'll have our inputs of last, say, 6 months, or that is called our database. We'll have a database of how the motor was behaving. Behavior in the sense, what was the current, what was the voltage, and when there is a breakdown. When there is a breakdown, what was the values of different values? Like what was the current, what was the voltage, and what was the torque? So our machine learning algorithm, which is basically worked on ML concepts, will start predicting when there could be some failure. Okay, that is the word predictive analytics. So we'll predict based on the history if there is a possibility of failure. Once we predict there is a possibility of failure, what we can do generate an alarm saying that this is going to fail. So now if I know somehow today or tomorrow there's a failure going to happen, what I can do, we don't need to wait for the failure. We can go ahead, fix the problems. So now most of the manufacturing companies are doing this using our IoT and also using machine learning algorithms. They're doing the predictions. So for predictions, we should have a database. We should have a clear database of some database which talks about how it works. What was the behavior? So based on the behavior, we are doing the analytics. So this data lakes will do the continuous monitoring, prevention, and prediction. This will be used completely. You can be used for one shop floor, one conveyor belt, or for the whole company. That depends on what all the data they want to do. So this is a continuous monitoring, prevention, and predictive things what we can do, right? So this is a general I've explained you. Going deep, how do you work? It's a complete subject which basically I can't explain in the 1 hour, 2 hours. We'll definitely, once you have a session, we can start working on that. So how it really industrial data lake works. Okay. Now I can take few questions, then I'll go to the other thing, and after that Kusuma will show the other applications. Yeah, any questions for me?
Yeah, yes, sir. What are the actual monitoring tools that we use to continuous monitoring? We have different types of tools, right?
Come again, little louder.
For continuous monitoring, we have different types of tools in our software. We have RAM and AWS, etc.
Continuous monitoring? No, I can't hear you, brothers. I'll need louder. Someone there, lab faculty, just attend him and see what is the sound problem. I can't hear you.
I think we have different types of continuous monitoring tools, right? Yes, sir. What type of tools we are using for?
The continuous monitoring is not a tool; it's a device. So there are multiple devices which are called sensors. So there will be multiple sensors. Suppose you want to measure temperature, you should fix a temperature sensor. You want to measure like voltage. You should fix a device, sensor which will measure the voltage. So based on the what type of parameter you have to use. You want to measure torque, you need to measure keep a device sensors which takes about, which will detect the torque. So based on what exactly you want to monitor, will be multiple devices will be there. You have to fix those type of devices, and these devices will emit a data about continuously it will be emitting the data. Maybe that also we can fix up. Maybe you want to measure temperature every 10 minutes, 10 seconds. So, or half a minute. So it will start emitting the data every half a minute. So it will send the data to half a minute and will bring all the data to a gateway. The gateway again here also there will be multiple type of data, multiple sensors will be there. Like something will be electronic data, so it will give electronic outputs. If something is a mechanical sensors, they will give a mechanical output, or the output could be different. So we have to build a middleware which talks about all those things, which understands it, and push that as an XML file. For this software, we'll take an XML files, or XML files usually we use as inputs, and then we'll do the monitoring. So the devices are multiple, and if you look into sensors, there'll be thousands of sensors available. Next.
Hello, sir. This
Yeah.
is Bharat.
Bharat, tell me.
Sir, we are talking about continuous monitoring, right? That means we are we are getting a lot of data. So our data lake is completely stored in cloud. For the just a clarification.
It could be cloud, Bharat, or it could be that requirement is based on the client. If the client wants in the cloud, they can push in the cloud, or they want, we can put in the local prem. That depends on how the client asks for us. We can do both.
Yes, sir. And what about the security protocol, sir? But it is a sensitive data, right? We are giving.
So that is why usually
now
every data. See, the first thing, all our data usually we are working on maybe healthcare data or manufacturing data. All these things is a sensitive data. The part we should have our software should undergo a lot of testing, and it should undergo vulnerability testings where there is no data leakage at any point of time. So any data our domains we are working as an Exafluence, we work on the healthcare data, it's more sensitive. And if it's a healthcare data, because it will have a patient's name and all those things. If it's a financial data, it's also sensitive. So we maintain all these protocols where there is no intrusion from external source. That is the whole subject of cybersecurity or vulnerability in our local systems where we have to maintain. That's a part of our design, and that has to be completely maintained. Any data which we will be working usually will have a ownership. No owner will be allowing other people to even look into it. So we should design our software so that there's no intrusions or nobody else will look into the data other than designated username passwords.
Yeah. Yes, sir. Got it. Thank you, sir.
Yeah. So guys, we kept. Yeah, go ahead. Yeah, tell me.
Hello, sir.
Tell me, Sumant.
This is Sumant.
Yeah, Sumant,
So,
tell me.
sir, this PLC has been coordinated with the sensors, which heaters and the temperature and the conveyor belts, right, sir? And this code has been written by them, or we need to.
We will see the. So PLC sometimes what happens if PLC will not, modern PLCs will get the most of the data. So from PLC we'll get the data into the, so there'll be not one PLC, right? Say suppose in a conveyor there are 10 machines, 10 PLCs will be there. So we'll get the data from the 10 PLCs, and we will be pushing the data into a data lake. From data lake we'll be doing our application. So it will start fetching the data from the middleware, where we'll be pushing multiple PLC data we'll bring in. If PLCs are not covering some of the data and we require to capture them, for example, so PLC doesn't like cover all the motors, or if it is not covering some of the things which is sensitive, we will fix up the external sensors and get the data to the middleware. From there, we'll take into the application.
Got it, sir. Thank you, sir.
Yeah. So when the real design comes, it will have more interesting things. So this is one of the project which is another area we are working in. So you have, so maybe we'll go to the next session. And one more, this is, can you see my screen, right?
Yes, sir.
This is a nothing to do with analytics, but totally a different subject, which is an interesting, which we are doing. We are working to work on this. See, this particular machine is basically, again, now you have I've shown you the small machine where you have that all the data coming in. But if suppose this is something image is small, this particular mission is a like 18-meter height. 18-meter height and almost like a 10 meters. So 18-meter, you can visualize it will be somewhere around 36 feet. Let's say almost like usual our average one floor of a building will be say 12 feet. So it's like a height of 33 to 4 feet, floors. The depth from the base to from this base to the top. So suppose this type of missions you are monitoring, this is an extension of continuous monitoring I'm talking about. So once this type of missions are you are monitoring thing, this is a 3D model of a mission completely. So what we do is we can real time identify where exactly which motor is a problem. So we are doing the, say, now we are talking about very small, say with thousands of component, thousands, like if not thousands, we say 100 motors are there in this thing. So we should be in a position to tell the operator which motor really which location, which motor. So suppose L2 motor, it will say L2 motor, he should be in a position to identify where is L2 motor to attend. So this type of 3D modelings also we do, where we exactly locate, but this is not exactly Exafluence capabilities. I mean about designing the 3D models. Our capabilities are basically getting the data into here. So what we do is we'll pinpoint which is the L2 motor. If you say motor L2, this 3D design will show exactly where is L2. So this is this type of capabilities which is an extension of continuous monitoring where we display the properly. So all these parameters will come into this, and the advantage one more thing what we are working on is called what if analysis. So there's a software called ANSYS. Maybe some of the mechanical people what you do must have heard about it. ANSYS, what we do here is, so suppose this motor is there. So I want to, this particular motor, it's what is happening is, you find there is a fan here, which is mixing there'll be 2-3 components coming. There's a water, there'll be a powder, 2-3 components and come and mix here. This is mixer actually. So and once you have a mixture, the properties are mainly like, usually mixing, what we'll do is for getting a uniform thickness or what you call as viscosity. So once this is water and other parameters are mixed, it's giving a viscosity. If I want to understand what will happen if I change that powder, if I'm putting in 10 kgs, what will happen if I put a 15 kg? So what we do is, analysis software, what it does is it builds the real time using the multiple components. It builds a 3D model of the machine, like a 3D or working model of a machine, where it will have all the mechanical properties, like what is the thickness of the plate, what is the plate strength, what is the if sheet metal is used, what is the sheet metal. So you will define every property and build a machine in our laptop and do the what if analysis. What really happens is, if I am putting a 10 kg, instead 10 kg, I'll put 15 kgs of powder and same water and ask the model to define what if I do this. So the analysis software works out with its models and gives the results. So now this will crash or it will break, or the strength of the folder or the say 12 sheet you have built the complete machine, it will not take, or the belts will break. So analysis is a specific software which will work on this. So we are partners with them, but this we are not attempted, but we are attempting getting the data. We have attempted getting the data into 3D modeling, but we are capable of doing the this what if analysis if really required. So some of you thermodynamics, when we are studied in the colleges, when you do the thermodynamics models, so usually we do the what if analysis of a when you construct a dam, what will happen if there is a change of inflow of water. All those things we are using in the analysis. So here we can use the analysis for mechanical IoT applications. So where we can use the sensors and get onto that. So these are the other capabilities what Exafluence has in IoT. Okay. So I'll go deep when you have into the classes of this happening. Maybe this is we just want to give you understand overview of Exafluence. So I just gave this.
Sir, excuse me, sir. Sir,
Okay,
just
tell
I
me.
want to ask you like this: like if hardware got a problem because of some XYZ issue, it will have impact on application, right? So if like it may generate like a different frequency when compared to past. So what our application does, it take that frequency, and when it comes to predictive analysis, how can it, well, like you people gonna deal with that wrong information with that wrong frequency what system has generated because of distraction or like damage, like natural damage or something like that?
So we'll have that condition now. Suppose so that is the data what we have, right? So the failure data what we call the failure data is for the reason. So failure mechanic, as you said, somebody has a mechanic done something or by mishap it has happened. So when a mishap happened, this is the parameters of the frequency or whatever we'll get the values. So that is a one data bank. So we should, when machine learning, so you know the concepts of machine learning, basic concepts, it understands different use cases or it understands the models and we'll try to build a model. So so anything machine learning learns itself from the data, which is a data bank, which is already there. So we are going to, we will have some, say, suppose there's a, what is the frequency when a mechanical mishap happened, we'll have that value. So if suppose we have a 2-3 such data, so where you will have, so this, we should build have a data of last 1 year or last 6 months, which will be used as a data bank for us to make the machine learning to algorithm to understand if such a scenario is happening, what has happened. So when there's a mechanical failure, these are the scenario. So our prediction model will say, when it is coming to this type of values it is getting, and it will say, now that this was the failure due to mechanical things. But mostly mechanical or this mishap things will not usually will be it's once in a time. So the major portions will be the what we prediction is what has happened when multiple failures. There was a failure because of the as I said again, motor bearing has gone. What was the parameters? If there is a other malfunction, if suppose there was a malfunction in the conveyor belt, so conveyor belt has slowed down. So this was the values when it is so production has come down. So then it will start giving the alarm. So there is a conveyor, it will say conveyor belt speed. So now the production will come down. So this could be different models, which can be based on the use cases. Clear?
No, sir. Like what I understand is it's all based upon the sensor. So sensor detect that and it sends the information. So like this part of the it got failure like that. What if that sensor got damaged?
So what we'll do is there's again a mechanical. Now we get say there is no value. Suppose there's a failure of the sensor. So what we get is like, yeah. So That's what I show you the low value or high values. Suppose what will happen if the sensors work? This current sensor, which is giving a 7.70 amperage. There's a failure of that sensor which is sending the data. It will become 0. Am I correct?
Yes, sir.
Immediately our flag will raise. Once this current is down, then the guy has to go whether it is because of the failure of a sensor or it's a failure of device. Then they'll start working. That is the main purpose of the whole thing. If there is no value coming out any sensor, there will be immediate flag for us. The flag will send indication that saying that there's no data coming in. So what are the sensors it should be, even from the PLC or from this, it will start sending the data. And we should predict once there is a failure, there's no input, then immediately there will be a flag.
Okay, sir. Even though we have like mission algorithms, like we are using supervised learning, if and all like if any physical damage is present, so physical person goes and rectify that. That's the
Yeah,
thing.
no, exactly. There's no way, no way where we can auto detect, right? So it will usually give an indication there's a failure. This guy, the maintenance people has to go physically, then do it. Autos, suppose there's a failure of sensors, machine can say it's a failed, but it cannot repair itself, right? The repair should be done by human. Either he should check there is any loose connection or it's completely burnt out or some mechanical devices, this guy has to do and do things. Okay. Yeah, these are the two parts. Now, Kusma, it's interest of time, you can start.
Thank you, sir.
Yeah, so we'll go into I'll just explain. Kusma will talk about another application of us. Kusma, can you share? And
Yeah, sure, sir. Thank you. Yeah, good afternoon, everyone. This is Kusma, and I'm handling SEM expert project in the IoT domain. So I think most of you know what is SEM, right? So that is supply chain management. Can anybody tell me what is the importance of SEM nowadays? Anyone?
Ma'am, it's more about like inventory management
Mm-hmm.
and transfer of goods when it's a shortage.
Okay.
Getting to know about the demands.
Okay. Yeah, thanks, Sumant. So, supply chain management. So, generally, supply chain management itself tells that it is a process with which we can integrate the process of getting the raw goods and delivering the final product to the end user, right? So, in between this process, there are a lot of things which will be integrated with multiple domains or multiple technologies. So we are using SCM, that is supply chain management, for our application, that is SCM expert, to track the shipment that is delivered, the different pharma related things and serums to various countries from Dr. Reddy's laboratories. So we are doing this SCM expert project for Dr. Reddy's laboratories. And so with this application, we can monitor the shipment. So that's why we can call it as SMAS project, which is shipment monitoring as a service. Here we can monitor the shipment and we can provide this shipment monitoring as a service. So with this application, so Dr. Reddy's people are able to track where is their shipment and how many days it will take to reach their destination and what are the quality parameters that are maintained in the shipment. Are those quality parameters are met in the shipment history or not? So these will be checked with the help of our application. So let me share my screen. So first I will, can anybody make me as a host?
you can present now, Kusma. No, you can't share that.
No, sir.
Someone in the lab can do that.
So it is personal. No, you could do that. You could say no. Please check.
Yeah, thank you. Yeah, is my screen visible?
Yeah, go ahead.
Yeah, ma'am.
Yeah, thank you. So, first I want to give you some insights on what is SEM and how we will use SEM in different sectors like IoT platforms. Then I will show you how my application will work on this. So, first of all, so what is shipment tracking and why we have to track the shipment? See, so we have to use supply chain management to get the visibility and reliability of our products. That means where is our product and when it will be arrived, right? So we have to know where is my shipment was, right? So when we use e-commerce related stuff, just like Myntra, Amazon, so there also we can track our products, right? So we will track our shipment. So where is my shipment? When will be the expected date? Does my shipment will receive today or tomorrow? And do I need to postpone my delivery? Something like that, right? So we will do all these things with the help of shipment tracking systems. The same thing we will do with SEM expert. And the next one, so with the help of SEM expert, we can monitor the shipment quality parameters. So whereas with the SEM expert, we are tracking the most sensitive products like drugs and serum. So here the most important thing is we have to monitor what is the temperature that is maintained within the container and what are the humidity parameters of the shipment. So these two parameters will be maintained with the help of SEM. Okay, so we have to monitor these two quality parameters with shipment quality. And the most important thing with the SEM expert is, so we have to reduce the cost of the shipment tracking. So generally, let's say for example, in the supply chain management process, if we have different departments, right? So let's say for example, there is a logistics department, there is a warehouse department, and there is a some quality department, and there is some testing department. So we have a lot of departments like this. If these departments are individual and these department has to integrate with one another and they have to complete the shipment, so it will take a lot of time. So in order to reduce that time and money thing, I mean everything, so we have to combine everything into a single platform, so where we can monitor and manage all the resources under one platform. Okay, so for that sake we are building this application. So with this we can reduce the cost, and with this we can reduce the supply chain partner assessment, and we can reduce the wastage, and we can reduce the shipment insurance cost. So these are all be reduced with the help of this application. So as per the index, if you observe in the bottom, so as per the SEM expert, so we have reduced so this many amount per year with the help of supply chain management systems. Let's say for example here, more than 50 billions of dollars, sorry, 50 billions of shipments, so never reaches its destination every year, right? So if we want to track those shipments, so it is not possible if there is no shipment mechanism at all. So if we have any shipment tracking mechanism, we can easily track our shipment. So where is it and how many days it will take to reach the destination, and what is the quality parameters are maintained during the shipment journey or not. So these will be checked with the help of our application. So this is a basic context regarding the shipment tracking. And so our SCM expert provide the following feasibilities for the end user. Let's see what are the major challenges in the supply chain management system and how SCM expert will give you the solution for the challenge. The first challenge is, where is my shipment now? So we have to find out the shipment location. So we need to track the real-time shipment location. We can do so the shipment tracking with the help of IoT sensors. So these sensor will track what is the GPS location of the shipment and how the quality parameters are maintained within the container. So with that, it will track the shipment parameters and when and how did it move. So it will track. So as I said, so it will track the GPS location. So it will find out the movement of the shipment. Let's say for example, the estimated date of the shipment is tomorrow. So today my shipment is in Tirupati. Maybe tomorrow it will reach to Chennai or Bangalore. So with this, we can monitor the shipment movement. And the third one are the quality parameters are recorded. So As I said earlier, so for every shipment, we will track some quality parameters like temperature, humidity, shock parameter, picture evidence, etc., etc. So with the help of this solution, we can monitor whether the quality parameters are recorded or not. If there is any missed parameter, what we have to do for that shipment. So that exception mechanism also included in the SCM expert. And did the shipment arrive? So if the shipment arrived in the respective destination, then we will do the final complete shipment phase. If not, what we have to do? So that mechanism also included in the SCM expert. So for that we have geofence. So this geofence indicates that, so whenever the shipment reaches in the geolocation of the particular destination, so then automatically complete shipment event will rise and the shipment will be get completed. So that the facility is included in our application. And once the shipment is arrived in the destination, so then we'll download all the shipment history, like, so what are the evidences that are attached with the shipment, and what are the quality parameters that are maintained throughout the shipment journey, and what is the final report of the shipment. So everything will be downloaded and it will send to the respective mail IDs, or we can do the same predictive analysis, everything, and we will submit all reports to the respective persons in the Dr. Reddy's laboratories. So this is our solution. And I want to show you so how the shipment journey will be. So I have divided the shipment journey process into 6 steps. So the first phase is preparation phase, and the second phase is shipment phase, and third is transit, fourth is exceptions, and fifth is goods receipt, and the fourth and the last one, return the device. In the first phase, that is preparation phase, so here we will prepare the shipment. So what are the product, what is the end product that we want to ship with the help of this application. So for that we need to find out what are the logistics we have to use for this and everything. So what are the quality parameters we will set. Let's say for example, for one shipment we will maintain 20 to 30 degrees temperature within the container. For some shipments we will maintain minus 10 degrees centigrade within the container. So like this, we have to set all the quality parameters, and we have to identify the partner with which we can ship our product, and we have to prepare what are the shipping documents, that is what are the documents that are we are attaching, that is invoices or something like that. So this is the phase 1 where we have to attach all this. And in phase 2, that is a shipment phase, so at the time of shipment, so we will attach one device, that is IoT device. Here in SCM Expert, we are using Piccolo IoT device to track the shipment journey. Okay, so this IoT device will be attached to the container, and so after attaching the container, so we have a screen in our application, that is create shipment screen. With this, we can create the shipment by entering all these parameters. And the next phase, that is a transit phase. So in the transit phase we have lot of events will arise, like we have to update the documents, we have to upload some FTA related documents, and we have to upload some IDE related documents. So these documents, everything will be uploaded with the help of update event shipment. So here we will update the shipment under various parameters. So once the shipment update is done, then it will move to the next thing, that is exceptions phase. So if there is any exception, or if there is any alert based on our restrictions, so it will give some alert message or some alert information to the respective mobile numbers or email IDs, saying that so this shipment is facing this kind of problem, so we have to do some remedy mechanism in order to overcome this problem. So this everything, this packing up of things will be done in the SCM expert itself. So if there are no exceptions at all, then we will go to the final phase, that is goods receipt. So here we will raise the goods receipt with the help of complete shipment option. So if we hit complete shipment, so it will generate all the reports based on the shipment parameters that are collected throughout the shipment journey. So with that, there will be a quality audit trial. So it will generate a graph whether the shipment is ready to receipt at the destination or not. If there are any quality parameters are not met, that shipment will not be receipt at the destination. So we will stop that shipment, and we will not use the drugs or serums that are shipped with that shipment. So if quality parameters are all met, then we will release that shipment. And then the final thing, that is the device that is attached with the shipment, will be returned to the UPS. So we are using UPS as a logistic service. So where we can collect our IoT device from UPS. So this is the general process. So these are the general steps that are in the complete supply chain management system. So from preparation to return device. So for every stage, we have developed a lot of screens in SCM Expert. So I will show you one by one.
Yeah, I'll explain a use case. Before Kuchma gets into the screens. So what is really happening is this use case is basically, for example, you may be thinking what is the use case? So we have used this particular application. When COVID was there, Dr. Reddy's labs, or not right away also, they do a lot of vaccinations. So vaccination should have a particular temperature should be maintained, say 5 degrees centigrade or -5 or something. Usually the tracking is completely used in the only for product. What we do in the Amazon or courier services, you will know where the device, but what is the shipment? What we are doing is specialized here is we are tracking the parameters, along with the where the shipment is, where we are tracking the we are tracking the temperature, we can track the humidity, we'll track the again the sensors or multiple sensors are available. The data, what I say, manufacturing data, how we are emitting and getting these type of sensors wherever the shipment is going. There will be a specialized SIMs which we will use. The SIMs will connect to the any network available in the journey from say India to US. So the SIM which IoT SIMs, the specialized SIMs will be kept on the trackers, which is the devices, and these devices will start emitting the data for which it has been designated. Suppose you have a temperature sensor, it will go on again the frequency what we ask, it will start emitting the data. So what will happen is that now we need to have a 20 degrees centigrade or 10 degrees should be maintained. When there is no 10 degrees centigrade is not maintained, it will push, we have the data, and if it is in the transit, we will understand where is the lacking, where is the, say suppose there is now the shipment is going from India to US, or it is in the Frankfurt airport, Germany airport, that we see that there is a reduction in the temperature, then there will be an alarm generated to the user, where the application user or the end user, saying that, boss, this your container is in Germany and your temperature is supposed to maintain at 10 degrees centigrade, but it is raising. You do some remedy. So the guy who is working for us will attend that particular shipment and see the temperature is maintained. So, and if all these parameters are maintained, then once it goes to the destination, so the end users will see all this tracking, we will have in the, say, a temperature from starting in India to US. What is the temperature it is maintained? If somewhere a reasonable temperature variation is there, they'll accept the goods. If it is not there, they'll reject. So the whole purpose of this is again IoT sensors, where we are tracking the properties, not exactly by properties. We are also tracking where the containers are laying, but there are now, again, as I said, there are a lot of sensors which are available, which track multiple parameters what we want to track. There is food people ask us to track something if food is spoiled, it will emit a different, say there's a food like meat is getting traveled. A meat, once there's a fail, the meat gets spoiled, it gives separate gas, smell or something. So there are sensors are available which will track this smell or gas and say this container which is meat is getting traveled is emitting this smell, which we have to discard this particular thing, or before that small emittings is coming, we'll start sending at the sensors, the inputs. So the use cases are multiple things where we are tracking multiple properties. So that is the use case what we are doing here. So the whole of this application is done by us, and now it is extensively used by Dr. Reddy's lab to track their vials to the all this so when what you call vaccines to the multiple locations from wherever they're used. So this is a sensitive. We are tracking the sensitive values of the containers, not the exactly shipment where it is and all. The shipment is it's also a part, but more our focus is on giving the containers data. I mean the properties of the goods which is getting traveled. So we'll use multiple sensors for multiple tracking. So that is the main application of this. Yeah, sorry, Kusma. You can go and show that thing.
Yeah, sure, sir. So this is the landing page of SCM Expert. So here we have a lot of tabs here. So the main tab is Shipments tab. So where we can create the shipment. So if you want to create any new shipment, so it will and the most important thing is, so we have successfully passed the VAPT test for this SEM Expert. So which is a vulnerability test that is conducted by one of the leading security firm, AppSecure. So this is the application. So this is the create shipment page. So where we can enter all the shipment parameters and we have to create the shipment. So manually, if you want to create a shipment, you can create a shipment like this, where you have to enter the delivery number and where you can select the route and where you can select the goods and devices. So here the device is nothing but it is a IoT device, and each and every device comes with its respective ID. So we can select the respective IoT device and that is attached to the shipment, and with that we can create the shipment. So if the shipment is created, it will show in this dashboard under the list of shipments. So for every shipment, we are maintaining some parameters like, let's say for example, if we click on this shipment, it is having some information here and it will show the map and what is the data that shipment is carrying and what are the documents that are attached with the shipment. So if you observe here, if you observe here, so this is the information. So what is the delivery number for the shipment and what is the IoT device that is used for this shipment and what are the different events that are created under this shipment. So here event is nothing but it is a supply chain management process. So once the shipment is created and then we have to attach the device and start the shipment, and we have to upload the respective documents that are relevant to the each and every phase. And so since it is a pharma related thing, so we have to attach the FDMA proceed documents also. And if everything is in place, then we have to raise the goods receipt. So if anything is missed in these steps, then we can use this event, that is additional document. So the missed documents will be uploaded as part of this event. So here we will get the partner name, and so this is the basic detail, and it will show the map here. So what is the start place and what is the end place, that is what is the source and what is the destination points within the map. And so it will show what are the data that is crucial data that is important for the shipment. So it will show like this. So what is the product name and what is the goods type here, so what is the temperature that is maintained here and what are the route details, and so this is the product name, and so this product is carried within this shipment. So like this we can get all the details here, and in the document section we will get what are the documents that are uploaded as part of that shipment. If there is no document for that shipment, it will not show any documents under this documents tab. So if you observe here, so this is the main thing, that is how the shipment quality parameters are observed means. So here we are creating a graph like this, so where we can fetch all the quality parameters from the start date of the shipment to the end date of the shipment. So if you observe here, so what is the time? So if you see here, so it will capture the date and time, and it will capture the device ID, and it will capture the delivery number, and what is the threshold. So for this shipment, we are maintaining the quality parameter as 20 to 25 degrees centigrade. So if any shipment doesn't meet 20 to 25 degrees centigrade, so we can raise an exception based on that. So there is, if there is any incursion or excursion values happen within these temperatures, and it will show the address of the shipment also, so where this particular shipment is, and so it is in Tirupati, and what is the temperature that is maintained within the container. So right now the temperature is maintained as 27.6. So it will show excursion like this. So if you want to show what is the incursion and what is the excursion values, we can show with red and green marks. So this is how we built the shipment parameters in the form of a graph. So this is the crucial component for this application. With this, we can check either all the quality parameters are met or not. So this is related to the shipment. And so if you see here, there is a setup option where we can set up all type of customers to this application. If you want to create any customer for this application, you can do so with the help of this customer option. And if you want to create any business partner, you can do so with business partner. And if you want to create any new route, let's say for example, I want to create a new route like Tirupati to Bangalore, so I can do so that in route master. If I want to add any new good, let's say for example, I have in the drop down like vaccine and serum, so if I want to add one more good to the drop down list, I can do so with the help of this goods master. And this is a geofence master. I can point out what are the points and what are the different geo parameters that are included with this shipment, so I can do so with this geofence master. And this is a reports page where we will get all the reports, like whether the shipment is met all the parameters or not. So those reports will be captured here. And this is the alert dashboard, so where we will get all the alerts based on the device or based on the thresholds that are maintained within the shipment. And this is the devices tab, where we have in use devices and available and received devices. As I said, so once the shipment, that is the consignment, is over, so the devices will be returned to the UPS. So that is handled with the help of this tabs. So this is whole application. So here we have two options. If the shipment is in live, it will show under this. If the shipment is already delivered, it will show under delivered section. Any doubts or concerns?
Hello, ma'am. Good evening.
Yeah, good evening.
This month, I have a doubt.
Yeah.
Ma'am, whether we can use a fuzzy logic to maintain the temperature.
Uh, why fuzzy logic here?
We are using sensors, no, ma'am.
Yeah.
In the case of this tracking this vials or this vaccine,
Yeah.
and you have set the threshold as for 20 to 25, let's say 20 to 25 centigrade.
Yeah.
And I'm using multiple sensors, and I'm using a fuzzy logic so that whenever it's crossing that threshold, I'm trying to maintain the temperature using
So
some coolers
here,
or something.
yeah. So here we need not to use any fuzzy logic. See, here we are maintaining temperature sensors, right? So each and every temperature sensor will capture some data. So here we are using Midlink as a firmware for this IoT sensors. So the data that is captured from the IoT sensors, we are capturing those details into MongoDB collections. So we are fetching all the MongoDB collection related, that is device data from the MongoDB collection, and we are processing the data based on our threshold values. And here we are filtering those data and we are showing in the graph here. So with this graph parameters, we can find out whether the quality parameters are met or not. So we are building our own logic. We need not to go for fuzzy logic kind of thing. It is very complex to implement. We need not that one.
Maybe with regards to the supply chain management, we are getting this data and we can give it to another team or another domain team so that they can try to implement this fuzzy logic thing.
See, actually, whatever the data that is captured from the IoT sensors, we are making one copy of the same data to the Dr. Reddy's. They will not do anything from their end. They will just keep that data for their reference purpose. So the report generation, everything that is done from our end with our own logic.
Okay, what is the logic? Why you want to use a fuzzy logic? You just can you explain
Yeah.
that?
Yeah.
What is your what
Sir,
do you think you can do with that?
sorry, sir, I didn't get you.
What is the reason you're thinking you can use the logic, and what do you achieve by that in this particular case?
Whenever there's a fluctuation in the temperature during based on the surrounding temperature,
Hmm.
we can use the fuzzy logic to maintain the in the
How do you
temperature inside the
maintain?
vial so that
How do you maintain?
we
Now
need
the,
multiple sensors
hmm.
to keep to track it inside the vial box or some container,
Hmm.
and in the we should keep track of the surrounding temperature, and we need to measure the temperature inside the vials,
Hmm.
and based on that we need to create a logic, and we need to uh, mm,
No, we'll
push it
create
into
a
the
logic for what? No, Sumant, what is the purpose of your logic? I'm asking. What you will do with that logic?
so that whenever there's a temperature being increased, I'm pushing down the temperature to the
How do you push?
uh, I'm going to add another cooler or AC or something which
How do
keeps
you do that? How do you do that?
When the shipment is in middle of the
Yeah,
ocean, how do you
but
do that?
let me answer that. So how do you add a cooler there? How do you do that? It's a mechanical process, right?
yes,
So
sir.
it's somewhere in the Germany, I said. Suppose it is laying in a Germany store, or it is in the in one particular cabin or one room of a German. It is in the shipment and it's laying somewhere. How do you add a cooler there? So the purpose here is basically we are recording the data. So we can generate an alarm, and our person who is there can mechanically prevent and go add a cooler, or he can do something. Our logic will not help there. Only an alarm will do, because we can't physically, our softwares cannot bring bring a cooler and add, right? The human should do that. So it will, what our application does is, so if a temperature is low, it will generate an alarm telling us in Germany, in particular city, in particular consigned box it is laying, and its temperature is growing, do something. Then it will generate an alarm for us, for all of us who are stakeholders like us and who is into the site there. It is generate an alarm. They go there and they'll work on that. Then they'll give a solution. So that is where we are getting the real-time data. And what will happen is, if we are saving all these real-time data, and the end client, when we are the data, the file goes to the final destination, and they will see what is the locations. Have you prevented or did something? Like suppose the vaccination cannot be, if more maximum life is 8 hours or 5 hours, it can withstand the multiple temperatures. If whether that vial or the container has gone more, like it has more than 12 hours or 24 hours, temperatures are raised. That is the values they look into. And if that value they see the data is more, or somewhere it is not maintained, they reject it. So our job, or this application job, is to record the data to exactly the sensors data should be recorded, and give an alarm. More than alarm, it cannot act, and maybe it will generate an alarm. Then the solution should be thought by human. Whether he has to go put in on air conditioners, or he'll add more air conditioners. Those things will be done by the humans there. Fuzzy logic cannot help there. You're getting us, right?
Yes, sir. I got the this supply chain application. What is doing is maintaining the records and giving a alarm. I'm suggesting or I'm asking is that can we do additional part? This is not for supply chain. It's for another like from there end
Another
itself,
domain.
No,
another domain.
what else if you can generate, so it can generate a signal, or it can generate, do something physically. Fuzzy logic in a box or our laptop can't do anything, right? Human interference, how it will do? What it can do?
For example, sir, based on the
Hmm.
fuzzy logic, we are having our ACs,
Hmm.
and with the help of a surrounding temperature, we can able to um, automatically feed a
No,
logic so that
yeah,
it decrease
okay.
the
Now,
temperature based on that.
if you are in the operation theater, okay, those things can be controlled. But in the particular SCM temperature, no, you have you have connected with the device, because you're in the air conditioner and you're connected with a device. You can control that. If all devices of IoT are connected to you, you can do that. But we are not in the airport. I mean, the flight will not give us a controls of their room controls of their air conditioner to change the temperature. If something is in your control, say suppose in operation theater or some closed environment where you have the IoTs, all devices under your control, you can do that. But particularly SCM use case, it is somewhere else. The devices are not in your control. The cooling device is not in your control, right? If you want to change the temperature of the, say it's a flight, if you want to change the flight temperature, is it in your control?
No, sir, I got that, sir. We are not having the control, but I was just asking, can we
Yeah,
do it that?
yeah, it's a small airports and something. I mean, sorry, operation theaters, fuzzy logics can be used where the devices should be in your control. That's a totally different concept as it together, not nothing into the SCM. Yes, if it is all devices are in your control, you can play around.
Yes, sir, got it, sir. Thank you.
Sir, I think a small addition to this topic, I think we can use AI to monitor the entire devices. That means we need to build a system. That means, as you said, the entire monitoring will be in the hand of a human. What if we replace the human and keep AI? That means AI system which monitors our sensors and take appropriate decision to reduce or increase the temperature of the vial or the container which we are shipping. So it
That
can be a possible solution.
there's a possibility, but if you all collaborate, the shipment, as I said, if it is in the flight, the airline should be should be in your control. You should collaborate with them.
Yes, sir. Got it. Yeah.
If doesn't, you don't have any collaboration with the flight air conditioners, you can't do anything, right? Whatever AAML, what are you talk about? Okay.
Yes, sir.
Yeah. Thanks, guys. I think Kusma, thanks. I think you have any more questions? Yeah, this portion, this is part of your curriculum. I mean, once you are maybe in second semester end and third, we'll start giving you the domain knowledge about this. Any of you are interested can be logged. So the sessions, what I'm going to give you, what we are introducing. I think the first class, my Prashant talked about all multiple things. Now we have done IoT. Next is Urmila will talk next Thursday about what is the applications we have in retail, and the next day there'll get Guy Kumar. He'll talk about healthcare, and there's a next class maybe Jeevan are involved. He'll talk about fintech. So multiple people will talk about multiple things what Exafluence is doing. So why I introduced these sessions is I want you to understand what are the multiple domains and what are the different use cases. Now once you start reading multiple maybe books or coming across multiple applications, so you can correlate with this what we are doing in Exafluence. And these domains what we want you to get on to when you are into the third and fourth semesters. This is my intention where I brought you all into this. Okay. So any suggestions you want to change here? Are you understanding the concepts?
Yes, sir. Thank you for that.
Okay, thanks a lot. Take care.
Thank you, everyone. Thanks.